When installing a subpanel in an existing panel in a residential house, there are several key considerations to ensure safety and code compliance. Firstly, regarding circuit capacity, the subpanel's capacity should generally be half or less than that of the main panel. For example, if the main panel is rated for 200 amps, the subpanel should be rated for 100 amps or less. This is a common practice to prevent overloading the main source. Secondly, concerning the separation of ground and neutral conductors, it is imperative to keep these circuits separate within the subpanel. Do not install a bonding screw or any other means of connecting the ground and neutral bars together in the subpanel. The neutral bar should be isolated from the subpanel enclosure. This separation is a fundamental safety requirement in subpanels. Thirdly, in reference to bonding bushings and the offset nipple between the panels, they are typically not required in this scenario. Bonding bushings are specifically utilized in situations where the neutral and ground conductors are bonded together, which is not permitted in a subpanel. The purpose of bonding bushings is to provide a low impedance path for fault current in metallic conduits and enclosures, but this is not necessary when the ground and neutral are properly separated. Grounding is a critical aspect of electrical safety. It provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse and to energize the circuit, preventing electrical shock and fire hazards. Grounding also helps to stabilize voltage and reduce electrical noise. The grounding system consists of several components, including the grounding electrode, the grounding electrode conductor, and the equipment grounding conductors. The grounding electrode is typically a ground rod, a metal water pipe, or a concrete-encased electrode used for ground. The grounding electrode conductor connects the grounding electrode to the neutral bus in the main panel. The equipment grounding conductors provide a path for fault current from electrical equipment back to the main panel. Neutral conductors carry the normal unbalanced current from the load back to the source. In a properly wired circuit, the neutral conductor should be at or near 0 volts potential with respect to ground. The neutral conductor is connected to the neutral bus in the main panel, which is also connected to the grounding electrode conductor. Bonding refers to the practice of connecting all metal parts of an electrical system together to create a common ground potential. This includes metal conduits, metal enclosures, metal equipment housings, and metal water pipes. Bonding helps to reduce the risk of electric shock by ensuring that all metal parts are at the same potential. If a fault occurs, the fault current will flow through the bonding conductors back to the source, tripping the circuit breaker or fuse. Several common grounding mistakes to avoid are: firstly, failing to properly bond all metal parts of the electrical system. This can create a shock hazard if a fault occurs. Secondly, using the neutral conductor as a grounding conductor. This is a dangerous practice that can create a path for stray current to flow through the neutral conductor, which can cause electrical noise and equipment malfunction. Thirdly, using undersized grounding conductors. Grounding conductors must be sized according to the size of the circuit conductors. Using undersized grounding conductors can limit the effectiveness of the grounding system and increase the risk of electrical shock. Fourthly, failing to properly tighten grounding connections. Loose grounding connections can create a high resistance path for fault current, which can reduce the effectiveness of the grounding system. It's important to torque all connections to manufacturer's specifications. Fifthly, grounding to a metal water pipe without properly bonding the water pipe to the electrical system. Metal water pipes can become energized if they are not properly bonded to the electrical system. This can create a shock hazard if someone touches the water pipe and a grounded object at the same time. The National Electrical Code (NEC) provides detailed requirements for grounding and bonding electrical systems. It is important to follow these requirements to ensure the safety of people and property. NEC Article 250 covers grounding and bonding requirements. This article provides information on the types of grounding electrodes that are permitted, the size of grounding conductors, and the methods for bonding metal parts of the electrical system. In a subpanel, the separation of the neutral and ground conductors is crucial for safety and proper operation. The neutral conductor carries the normal unbalanced current from the load served by the subpanel back to the main panel. The ground conductor provides a path for fault current to return to the main panel, tripping the circuit breaker and protecting against electrical shock. When the neutral and ground conductors are bonded together in a subpanel, it creates a parallel path for neutral current to flow through the ground conductor. This can cause several problems, including firstly, electrical noise. The flow of neutral current through the ground conductor can create electrical noise that can interfere with the operation of sensitive electronic equipment. Secondly, ground loops. A ground loop is a condition where there are multiple paths for ground current to flow. This can create a difference in potential between different points in the grounding system, which can cause electrical noise and equipment malfunction. Thirdly, increased risk of electrical shock. If the ground conductor is carrying neutral current, it can become energized. This can create a shock hazard if someone touches the ground conductor and a grounded object at the same time. To properly separate the neutral and ground conductors in a subpanel, follow these steps. 1. Install a separate neutral bar and ground bar in the subpanel. 2. Connect the neutral conductors from the branch circuits to the neutral bar. 3. Connect the equipment grounding conductors from the branch circuits to the ground bar. 4. Do not connect the neutral bar to the subpanel enclosure. 5. Do not install a bonding screw or strap between the neutral bar and the ground bar. The neutral bar should be isolated. In addition to separating the neutral and ground conductors, it is also important to properly size the grounding conductors. The grounding conductors must be sized according to NEC Table 250.122, based on the size of the circuit conductors. It is also important to properly toggle grounding connections. Loose grounding connections can create a higher resistance path for fault current, which can reduce the effectiveness of the grounding system. Always use a calibrated torque wrench to ensure that grounding connections are properly tightened. Bonding bushings are used to bond metal conduits and enclosures to the grounding system. They provide a low impedance path for fault current to flow back to the source, tripping the circuit breaker and protecting against electrical shock. Bonding bushings are typically used when the metal conduit or enclosure is not properly grounded through other means. For example, bonding bushings may be used when the conduit is connected to a metal box with non-metallic fittings. Bonding bushings are not necessary when the metal conduit or enclosure is properly grounded through other means. For example, bonding bushings are not necessary when the conduit is connected to a metal box with metallic fittings and the box is properly grounded. In the case of an offset nipple between two panels, bonding bushings are generally not required if both panels are properly grounded. The offset nipple is typically a short piece of conduit that connects the two panels together. If both panels are properly grounded, the offset nipple will be effectively grounded as well. However, it is always a good idea to check with a local electrical inspector to verify whether bonding bushings are required in a specific situation. Some local jurisdictions may have specific requirements for bonding metal conduits and enclosures. There are several types of bonding bushings available, including firstly, standard bonding bushings. These bushings have a set screw that is used to tighten the bushing onto the conduit. Secondly, insulated bonding bushings. These bushings have an insulated throat that protects the conductors from abrasion. Thirdly, lay-in bonding bushings. These bushings have a lay-in lug that allows the grounding conductor to be easily installed. When installing bonding bushings, it is important to follow the manufacturer's instructions. The bushings should be properly tightened onto the conduit to ensure a good electrical connection. The grounding conductor should be properly connected to the bonding bushing and to the grounding system. In summary, when installing a subpanel, remember to keep the capacity within half or less of the main panel's rating. Always keep the ground and neutral separate in the subpanel, avoiding any bonding. Bonding bushings are generally not required for the offset nipple between panels if both panels are properly grounded. Adhering to these principles ensures a safe and compliant electrical installation. Always consult the NEC and local electrical codes for specific requirements in your area, and when in doubt, seek guidance from a qualified electrician.